The last type of function that we're going to study is something called an exponential function. And part of how it gets its name is that your exponent is where your independent variable, or x, is. So I like to think that it's exponential because x is in the exponent. And just like we have slope and y-intercept with a line, we have important things in our exponential function equation. The first thing is what we call the a, which is our initial or starting value. Initial value. The other thing we have is what we call our growth or decay factor, which is b. We also call this the multiplier, and we will see why in a second. The growth or decay factor, or the multiplier. And then we have x and y as usual. Let's look at what one situation is that we call exponential growth. And this is when b, our base, is greater than 1. For instance, let's say we have something like y equals 2 to the x. Then, if I filled in a table, I'm going to start at negative 1. 2 to the negative 1 would just be 1/2. 2 to the 0, anything to the 0 power is 1. Anything to the first power is just itself. 2 squared means 2 times 2, which is 4. 2 cubed means 2 times 2 times 2, which is 8. And then I'm going to multiply that by 2, and multiply that by 2. So if I look at my change in y, what is happening every time to get from one y to the next is not like I'm adding something the same every time like it was with a line. I'm multiplying by the same thing every time. So let's graph that and see what it looks like. And with exponential functions, we just have to kind of estimate a little bit. So like 1/2, that means kind of, and I'll see if I can do this with my pen real well. There we go. Halfway up. And then I have 0, 1. And then I have 1, 2, and then I have 2, 4, and then I have 3, 8. You have to forgive how this is a little bit messy because of my pen. Okay, and if I connect those, I get this type of curve. That's supposed to be an arrow, y'all. Bear with me. Okay, do you see how it starts getting... It's not really growing very much as I go from left to right, and then all of a sudden it shoots up. So that's what an exponential function will look like on a graph. Let's look at one more table. How about y equals 3 to the x? And I'm going to start at negative 2 this time. This means 3 to the negative 2 means I need to put the 3 in the bottom and then still square. So that'd be 1 over 9. I'm not going to do decimals. If you want decimals, whatever. Negative 1 would mean 1 over 3. Something to the 0 power is always 1. Raise 3 to the first power, and I get 3. If I square 3, I get 9. If I cube 3, I get 27. And if I raise it to the fourth power, I get 81. Look at what I'm doing each time here. I am going up. And you see how I'm going up slowly, and then all of a sudden I've gone from 1 to 81 so quickly. Times 3, times 3, times 3, times 3, etc. I'm not going to write all those times. And, we said that b is also called the multiplier. It's because I'm multiplying by 3. Look at what my base is in my equation. Okay? When I look at a word problem, the key words that tell me it's exponential growth are increasing, growing, appreciate, and multiplying. Those words tell me it's growth, and usually exponential growth versus linear growth. One more thing about my graph. Do you see how it's getting really close to my x-axis right here? That's what we call an asymptote. Okay, we draw it as a little dotted line like that. It's A, S, Y, M, P, T, O, T, E, asymptote. And that just means it's something that my graph approaches. As my x's get more and more negative, it goes towards that x-axis. Now let's see what exponential decay looks like. How about using y equals 1/2 to the x? So I'm going to start at -3. This means I need to flip the top and the bottom, so that would give me 2 cubed, which is 8. 2 squared, which is 4. 2. Anything to the 0 power is 1. Anything to the first power is itself. If I do 1/2 times 1/2, I would get 1/4. And don't stress too much about getting this table at this point. I'm just kind of trying to show what the pattern is. And what would make sense if my base is my multiplier is that I would multiply by 1/2. Let's see. 8 times 1/2 is 4. 4 times 1/2 is 2. Another way I can think of it is dividing by 2, right? Because multiplying and dividing are inverses. Divide by 2. Okay, so multiplying by 1/2, dividing by 2. Let's look at another table. Y equals 1/3 to the x. This time I'm going to start at -4. That's going to give me 81. -3 is 27. -2 is 9. -1 is 3. 0 is 1. 1 is 1/3. And 2 is 1/9. So what's happening to my numbers every time? I'm dividing by 3. Or I'm multiplying by 1/3. And I'm going to graph y equals 2 to the x, or 1/2 to the x. I'm going to do this first one. So the one I'll be able to start with is -3 and up 8. Then -2, 4, and you'll be able to count this better than I can. My graph is not turning out well. -1, 2, 0, 1. Notice they've both gone through that point 0, 1. 1, 1/2. And then it just starts getting really, really close to my x-axis, which once again we call our asymptote. So as I go from left to right, it is decreasing. It's getting smaller. And here's my lovely asymptote. It's approaching that. So it's never going to become a negative. The ways I know that it is exponential decay from a word problem are key things like decreasing, decaying, depreciating, oops, I totally spelled that wrong. There we go. Depreciating. And shrinking. And I'm going to take one more minute to get you started on the back of your first page where we just wrote what A and B meant. So I'm just going to get you started with these. It didn't turn out well on my copy, so bear with me. Y equals 4 times 0.5 to the x. And the instructions say to highlight the growth decay factor and underline the initial value. If you want to just use 2 types of highlighters, that's fine. So my initial value is 4, and my growth or decay factor is 0.5. Since 0.5 is less than 1, that means it is decay, which means from left to right it's decreasing. To go across and fill in the parts of my table. Looking at the next one, y equals 3 times 1.75 to the x. Initial value is 3. My growth decay factor is 1.75. 1.75 is greater than 1, so we would say it's growth, which means it is increasing. Has nothing to do with what is going on in front. Let's do one more together, and then I'll let you do the rest. Y equals 2.65 times 3 to the x. Once again, sometimes you need to use your brain. Do I have 2 multiplication? No, this is a decimal. That's a times. You should be able to see that. Okay, initial value, let me get the color to work, 2.65, and my growth or decay factor is 3. 3 is greater than 1, so it's growth, which means it's increasing as we look from left to right. So go ahead and finish those last 3 problems. Identify your initial value, your growth decay factor, whether it is growth or decay, and whether it's decreasing or increasing, and come ready to do more practice tomorrow.